1.5 direct injection turbocharged diesel engine, direct injection turbocharged diesel engine, 6.0 L power stroke V8 POWER stroke V8 6.0 L. Horsepower and torque will remain unchanged throughout the 2004 model year on F-Series Super Duty trucks. The 6.0 L power stroke engine creates 325 HP at 3,300 RPM and 560 feet per pound of torque at 2,000 RPM. Due to more stringent federal emissions standards, the 6.0 L power stroke engine has undergone many updates during the 2004 model year. The 6.0 L power stroke engines are manufactured at two locations, Indianapolis Engine Plant in Indianapolis, Indiana and International Diesel of Alabama in Huntsville, Alabama. The serial number breaks for the updated 2004 6.0 engines are 6,155,637 for Indianapolis-built engines and 0094580 for Huntsville-built engines. The beginning production date for the updated 2004 Power Stroke engine was on September 29, 2003. This publication is not intended to replace the service manual but to introduce the updates to the 6.0 L Power Stroke engine. Horsepower and torque. New 6.0 engine features 6.0 L power stroke engine, 6.0 L POWER stroke diesel EGRTP, exhaust gas recirculation throttle plate, redesigned high-pressure oil rail and delivery system, redesigned EGR cooler, DLC coating on injector plunger. 2003 mid-year improvements, 2004 running changes and updates, 2004 6.0 Econoline, updated 6.0 engine specifications, update features 4 horsepower and torque, 6.0 L power stroke direct injection turbocharged diesel engine 2.6. Component location. Left front of engine. 2, 3, 1, 1, 2, 3, 1. FICM fuel injection control module mounting brackets. 2. EGR throttle position sensor. 3. FICM fuel injection control module. 5, 6. Left rear of engine. 1. Crankcase breather. 2. Glow plug harness. 3. Rear FICM mounting bracket. 7. 1. ICP sensor. 2. EGR-TP EGR throttle plate actuator. 3. GPCM bracket. 1. Glow plug harness. 2. Emissions label. 3. Glow plug control module GPCM, right front of engine, right rear of engine. Component locations 788, 132, 132. Component location. Top of engine. 3, 2. Eliminated bolts. 1, 9, 10. 1. EGR cooler. 2. Intake manifold. 3. Compressor inlet hose. Upper oil pan. The 6 M8 bolts which were placed in the center of the upper oil pan have been eliminated. Additional strength has been cast into the upper oil pan. An upper oil pan which has bolt holes present should always be assembled with the 6 specified M8 bolts. Failure to do so will result in a vibration-related noise caused from the upper oil pan vibrating against the bed plate. An upper oil pan which has had the bolt holes eliminated can be utilized as a service part to replace the earlier part. 9. 2004 Power Stroke features. Camshaft. The lobe separation angle, lobe lift, and duration have changed to improve combustion characteristics. Changes have been made to the camshaft to increase the efficiency of the 6.0 L engine, allowing it to meet tighter emission standards. It is not recommended that the updated 2004 Mi camshaft be installed into an earlier version of the 6.0 L engine. Emissions will be impacted. Piston combustion chamber. The combustion chamber on the piston has been modified. This modification increases the efficiency of the combustion process, allowing the 6.0 L engine to meet tighter emission standards. Glow plugs. Due to the design change of the piston, the glow plug has been made shorter by 1.2 millimeters. Note: if the longer glow plugs are installed into an engine with updated pistons, glow plug to piston contact will result, ending in potential catastrophic engine failure. Original BOWLDESIGN. Original BOWLDESIGN. Updated BOWLDESIGN. Updated BOWLDESIGN. 11, 12, 1.2 millimeters. 13, 10. 1516 GPCM glow plug control module bracket. The GPCM bracket has been modified to accept the repositioning of the ICP sensor. An earlier GPCM bracket will not work on an updated 2004 Mi engine. The FICM brackets are now composed of 2 bottom pieces and 2 smaller top pieces. The bottom brackets are pictured here. They slide over valve cover bolt studs as did the previous brackets. The new brackets have larger vibration insulators at each valve cover mounting point. The water pump impeller diameter has increased in size to 100 mm from 90 mm. The larger impeller will increase coolant flow through the engine, which will offset higher heat rejection. Note: both water pumps have the same bolt pattern, but a different sealing area. As a result, the smaller water pump has the physical ability to be installed into an updated front cover. If this is done, a coolant leak and overheating of the engine may result. FICM Fuel Injection Control Module brackets water pump front cover 2004 powerstroke features 1411 FICM mounting BRACKETS FICM mounting brackets ICPSENSOR GPCM mounting GPCM mounting bracket FICM ELECTRICALCONNECTORS FICM ELECTRICALCONNECTORS X3X2X1 X190 100 mm. Notes 12. 1819 Turbocharger oil supply line. Installation. Once the oil supply line has been pressed into the cooler, the collar should be positioned and the retaining bolt installed. Prior to tightening the retaining bolt, reposition the oil supply line, as necessary, in order to install the two turbo-mounted oil supply line bolts, located on the center section of the turbo. Torque all bolts to specification. First, apply oil to the oil supply line O-ring. Orient the supply line where it will be positioned once fully installed. Press the supply line O-ring into the cooler. Partway through the 2003 model year, the turbo oil supply line changed in design. The early design was a quick connect-disconnect style left. The improved design right provides a larger O-ring seal and is held in place with a bolted down collar. The new design improves the line's long-term reliability and reduces risk of oil leaks between the oil cooler assembly and the supply line. Turbocharger oil supply line. Installation. Turbocharger oil supply line 2003 MYRUNNING changes 1713 OILCOOLER hold down BOLTHOLD down bolt quick connect fitting hold down collar 2003 My running changes. Wiring harness routing. Early production 2003. From the beginning of the production of the 6.0L powerstroke engine, the wiring harness has been comprised of two combined smaller harnesses. Both of these smaller harnesses were routed between the oil filter housing and the secondary fuel filter housing. Late production 2003 and 2004 My. In order to increase serviceability and long-term reliability of the engine wiring harness, the two harnesses were separated. The injector harness, which runs from the FICM to each of the 8 injectors, is now routed between the oil filter housing and the compressor housing of the turbocharger. Injector clip orientation. The orientation of the injector connector retaining clip has been repositioned in order to improve serviceability. Prior to this change, the clip was positioned on the side 9 o'clock position of the connector. This made removal and installation of the injector connector more difficult on some cylinders. Injector harness. Asterisk 2004 engine shown. 20. 21. 9 o'clock clip. 12 o'clock clip. 14. 22. 23. 24 injector clevis. A change was made to the injector clevis midway through the 2003 My. The revised clevis in the injector improves the lateral support of the plunger and dramatically reduces injector scuffing. Midway through 2003 My, the sleeve in the high-pressure pump cover was removed. The sealing surface for the high-pressure oil discharge tube is now totally machined for the O-ring seal. From the beginning of production, the high-pressure pump cover retains a sleeve which provides a sealing surface for the O-ring on the high-pressure oil discharge tube. High-pressure pump cover without sleeve. High-pressure pump cover with sleeve 2003 MYRUNNING changes OLDCLEVIS OLDCLEVIS 2515 SLEVE no SLEVE sleeve. Note 16. Air Management System. 6.0L Air Management System features. External mounted crankcase breather. Redesigned intake manifold. Improved turbocharger sound characteristics. Redesigned EGR cooler. From charge air cooler. 26. Compressor inlet. Turbine outlet. EGR cooler. Air management system features. The crankcase breather has been externally mounted on the left valve cover. The rear crossover section has been removed from the intake manifold. The updated 2004 My Powerstroke engine has been equipped with a EGR throttle plate. Air management system flow. Throttle body. EGR valve. Compressor outlet. 27. 17. Air management system. Compressor inlet hose crankcase breather hose. In order to accommodate the change from an internal crankcase breather to an externally mounted crankcase breather, the compressor inlet hose has been modified. The compressor inlet hose bracket is also utilized as a retaining bracket for the front two mounting points of the FICM. Compressor inlet hose removal. To disconnect the crankcase ventilation tube from the engine, remove the air inlet tube from the compressor inlet and rotate the vent hose counterclockwise until it releases. Note: since the 6.0L Powerstroke engine uses a closed crankcase ventilation system, it is normal to see oil carry over in the inlet air system. External mounted crankcase breather. The crankcase breather was externally mounted on the valve cover because of the redesign of the high-pressure oil rail. Internal breather. External breather. Crankcase breather hose. FICM mounting brackets. Crankcase breather. 28, 29, 18, 30. 313233 turbocharger exhaust turbine wheel. 3 fins have been added to the turbine wheel of the turbocharger. These additional fins were added to the turbine wheel in order to improve the turbocharger's sound characteristics. The intake manifold is now equipped with an EGR throttle plate. The purpose of this plate is to lower the manifold pressure, which will allow exhaust gases from EGR to flow freely into the intake manifold. Note: the PCM will activate the EGR TP actuator and perform a full sweep of the throttle plate for each key cycle with the IAT temperature greater than 0 degrees Celsius 32 deg. The intake manifold has been modified for the updated 2004 My. The crossover section at the rear of the manifold has been eliminated. EGR throttle plate intake manifold air management system 19 EGR throttle PLAT EGR throttle plate turbine BLADESTURBINE blades no rear crossover ERNO rear crossover. Air management system. EGR coolers. The EGR cooler has been lengthened for the updated 2004 My engine. The changes to the EGR cooler will cause the exhaust gases to be cooler before entering into the intake manifold. EGR cooler exhaust connection. Because the new EGR cooler is longer than the original, the exhaust up pipe is shorter in length at the EGR cooler connection than the original up pipe. The new EGR cooler still utilizes the same V-band clamp. Updated EGR cooler mounting. With exception to the exhaust up pipe connection, the updated 2004 EGR cooler installs in the same location as the original EGR cooler. Longer EGR cooler. Shorter exhaust extension. 34. 35. EGR cooler coolant supply. EGR cooler exhaust connection. EGR cooler exhaust connection. 20. 36. Air management system. 37. Rear turbo mounting bolt. Spacers. 38. No spacers. 39. EGR cooler, cooling system flow. Coolant flows out of the filter base and into the EGR cooler through a tube that directs the coolant to the back of the EGR cooler. Coolant flows through the EGR cooler and removes heat from the exhaust gases before the gases arrive at the EGR valve. Coolant exits the front of the EGR cooler and enters the coolant passage of the intake manifold. The intake manifold directs the coolant back into the front cover. Turbocharger mounting bolt. The turbo mounting joints have been modified. The mounting bolts no longer need spacers on the new turbo. Turbocharger mounting bracket. A new turbo mounting bracket has been implemented with the mounting bolt spacers incorporated into the bracket. These spacers are utilized to achieve the necessary clamp load on the turbocharger mounting bolts. 21. Notes 22. Wavy high-pressure oil rail, redesigned standpipe branch tube, relocated ICP sensor, DLC-coated injectors, 40 FUELMANAGEMENT system, high-pressure oil system. The high-pressure oil rail has been redesigned to increase oil capacity and to reduce noise. The standpipe serviceability has been improved. The ICP sensor has been relocated to the right valve cover, high-pressure rail. DLC, diamond-like carbon-coated injectors. 6.0 La high pressure oil system, 41 high pressure oil system flow, 23 rear of engine high pressure OILRAIL high pressure OILBRANCH tube high pressure standpipe. 4244. The high-pressure standpipe is a two-piece pipe that is sealed to the high-pressure rail and high-pressure branch by O-rings. The standpipe is installed after the new wavy high-pressure oil rail has been installed and torqued to specification. The standpipe has a check valve inside to limit hydraulic disturbance feedback from injector operation. Note: do not disassemble the high-pressure standpipe. This will cause damage to the internal components of the pipe. If at any point, the high-pressure rail has been redesigned to reduce noise through the high-pressure oil system. The volume wavy high-pressure rail has increased from 15 cubic inches to 30 cubic inches. This reduces pressure fall-off during injection and improved emissions and fuel economy. Note: the larger volume oil rail will increase engine start time after the high-pressure oil rail has been drained during the process of any repairs. High-pressure standpipe wavy high-pressure rail FUELMANAGEMENT System 24 High-pressure OILRAILHIGH Pressure OILRAIL Stand PIPESTAND Pipe Right bank shown. Rear PORTREAR Port Front PORTFRONT Port. The wavy high-pressure oil rail has special AWA acoustic wave attenuation features to dampen hydraulic noises. The wavy high-pressure rail uses two AWA fittings, a large one and a small one. The AWA fittings are placed in the center of the rail. The smaller AWA fitting is placed in the wavy portion of the rail while the larger AWA fitting is placed in the original portion of the rail. The wavy high-pressure rail utilizes 4 specially designed end caps in conjunction with the AWA fittings. Wavy high-pressure oil rail with dual AWA fittings 43 RAILEND caps AWAFITTINGS. 454647. The front port plug is located towards the front of the high-pressure oil rail. The rail was designed to be universal for both sides of the engine. One side of the high-pressure rail must be blocked off when not being used with the standpipe. Note: the front port plug is longer than the rear supply port plug. If the front plug is installed into the rear port opening, damage to the standpipe and branch tube can result. There are 2 new high-pressure oil rail plugs introduced with the redesign of the rail. The rear supply port plug, on the right, allows high-pressure oil to flow into the high-pressure rail. The same high-pressure oil rail is used on both banks of the engine. As a result, the front port plug, on the left, is used to block off the non-utilized supply port in the high-pressure oil rail. Front port plug, rear supply port plug, high-pressure rail plugs FUELMANAGEMENT System rail. Its purpose is to allow high-pressure oil to flow into the high-pressure rail. During engine operation, a small gap remains between the rear supply port plug and the standpipe. The force of the hydraulic pressure keeps the standpipe seated into the branch tube. The plug will assure that the standpipe remains in place when the engine is shut off and not operating. 50. The same high-pressure pump cover is used. Since the ICP sensor has been relocated to the right bank high-pressure rail, a brass plug will replace the ICP sensor. The ICP sensor is installed over the gasket. The ICP sensor can be removed and installed without the removal of the valve cover. After torquing the ICP sensor to specification, the valve cover gasket and valve cover can be installed over the sensor. High-pressure pump cover ICP sensor, valve cover assembly FUELMANAGEMENT System IPRVALVEIPR valve brass PLUGBRASS plug ICPSENSOR ICPSENSOR ICPGASKET ICPGASKET 26 ICPGASKET ICPGASKET 49. The ICP sensor has a new gasket. The purpose of the ICP gasket is to seal the valve cover to the high-pressure rail and prevent the release of crankcase vapors or splash oil. Note: it is important to apply a thin layer of oil to both sides of the ICP sensor gasket during installation to prevent damaging the gasket. ICP sensor gasket 48. Fuel management system. Heat shield snap. High-pressure PUMPGEAR. High-pressure PUMPGEAR. Barrel. Plunger. IPR heat shield. The IPR has a new removable heat shield wrapped around it to help block excessive heat from the exhaust. If the IPR has to be replaced, the shielding will have to be removed from the old IPR and installed on the new one. Simply unsnap the button and slide the shield off. 51. 52. 53. High-pressure pump. The high-pressure pump utilized with the new wavy high-pressure rails will have the capability to produce increased oil pressure over the original high-pressure pump. DLC, diamond-like carbon-coated plunger. The injector plunger has had a DLC coating applied to it. The coating will further increase the robustness of the injector against poor fuel quality, water intrusion, and will reduce the risk of internal scuffing. 27. Notes 28. Electrical components. Electrical components. Sensors. Actuators. Glow plug system. PCM. FICM. ICP. EP. EGRVP. EGRTP. Sensor overview. PCM powertrain control module. Generation 2 electrical components. The PCM uses information from the sensors to decide which commands to send to the FICM, the actuators, and the glow plug system. Modifications and additions have been made to some electrical components. 54. INTRUMENT cluster. RPM. MAF and IAT1. BP. MAP. AP. EOP switch. MPH. EOT. Sensor overview. CMP. The PCM sends a VREF of 5.0 volts to 4 engine-mounted sensors, ICP, EP, EGRVP, and EGRTP. It also sends a 5.0 volt reference signal to 4 chassis-mounted sensors, MAF, BP, MAP, and AP. CKP. ECT. IAT2. 55. IAT1 is not used in any engine control. The IAT1 signal is used to assist in the operation of the air conditioning and engine cooling fan. The PCM uses 5 volts in order to maintain consistency throughout all operating conditions. The VREF is conditioned by the sensors, then returned to the PCM for use in determining the fueling strategy and/or actuator duty cycle. The EGRTP exhaust gas recirculation throttle position sensor is added. MAF is not used in any engine control. MAF is used in the EGR monitor strategy to calculate the total clean air going into the engine. Once the total clean air is known, the amount of EGR required can be calculated. Note: failure in either or both of these components has no effect on engine performance. 29. ELECTRICALCOMPONENTSEGRTP exhaust gas recirculation throttle position sensor. The EGR throttle position EGRTP sensor is a potentiometer that provides a feedback signal to the PCM. The input signal is an analog voltage proportional to the rotary position angle of the throttle plate located within the throttle body. EGRTPSENSOR PCM powertrain control module MIL malfunction indicator lamp EGR throttle position EGR throttle and sensor 563057. Glow plug wiring harness. In order to increase the serviceability of the glow plugs, the glow plug bus bar has been replaced with a new glow plug harness. This will provide flexibility in the harness, to ease removal of glow plugs. In addition, the rocker arm carrier has been modified to improve accessibility to the glow plug harness. Note: the glow plug bus bar and the glow plug wiring harness are not interchangeable parts and should only be replaced with the correct replacement part. The EGR throttle plate is designed to assist with EGR operation. The egret actuator modifies the intake airflow from the charge air cooler into the intake manifold. The egret actuator regulates the rotary motion of the throttle plate located within the throttle body. The control of intake airflow provides increased EGR system efficiency with the throttle plate position determined by a signal from the EGRTP sensor. Actuators convert electrical output from the PCM to hydraulic, mechanical, or electronic work. The 6.0L powerstroke engine now uses 5.5 actuators: injection pressure regulator (IPR), exhaust gas recirculation (EGR) valve, variable geometry turbocharger control valve (VGTCV), glow plug control module (GPCM), and the exhaust gas recirculation throttle plate (EGRTP) actuator. EGRTP exhaust gas recirculation throttle plate actuators ELECTRICALCOMPONENTS 6059 injection pressure regulator IPR exhaust gas recirculation valve EGR variable geometry turbocharger control valve VGTCV glow plug control module GPCM exhaust gas recirculation throttle plate EGRTP EGRTPACTUATOR throttle PLATEGR throttle plate glow plug CONNECTORSGLOW plug connectors 58 actuators 31. Electrical components. ICP sensor. The ICP sensor is no longer located in the high pressure pump cover. It has been relocated to the front on the right high-pressure oil rail. The valve cover and GPCM bracket sets over the ICP sensor. High-pressure PUMPCOVER. High-pressure PUMPCOVER. ICP sensor. GPCM. 6132. The 6.0L diesel engine will be a new addition to the Econoline starting in 2004. The Econoline will feature a charge air cooler for the first time. The Econoline 6.0L diesel engine will feature visual differences versus the F-Series. The Econoline 6.0 utilizes a remote mount oil filter. Econoline 6.0L DIESELENGINE33 remote mount oil filter charge air cooled chassis mounted FICM 2004 6.0 Econoline features 2004 6.0 Econoline features 6362 Econoline 6.0L powerstroke diesel. Econoline component location 34653216624311. EP exhaust pressure sensor 2. GPCM glow plug control module 3. 12-way connector 4. Battery power junction point left of engine 1. Upper oil pan 2. Oil filter cap 3. Oil to filter supply line 4. Clean oil to engine line remote mount oil filter 464 horsepower and torque. The Econoline 6.0L powerstroke engine creates 235 HP at 3150 rpm and 440 feet per pound of torque at 1600 rpm. Econoline component location 2, 3, 4, 4, 1, 2, 1. Left front of engine 1. EP exhaust pressure tube 2. Oil level gauge and tube 3. 46-way PCM connector 4. Upper oil pan 67. 3. 68. Left rear of engine 1. FICM electrical connectors 2. Oil filter housing 3. Remote mount oil filter oil lines 4. Vehicle battery power junction point 35. Econoline component location 36702-431-69312 right rear of engine 1. Glow plug harness 2. Block heater 3. Secondary fuel filter housing 4. Turbine outlet 1. Oil fill adapter 2. EGR throttle actuator 3. Heater return right front of engine. 72. The 2004 Econoline 6.0 utilizes the same integrated oil cooler that is used in the F-Series application. Due to space limitations, the canister-style oil filter must be remote-mounted to the upper oil pan on the driver's side of the engine. Lubrication system. Flow lubrication system features Econoline lubrication system 37, integrated oil cooler, remote mount oil filter, canister style oil filter. Lubrication system features 71, remote mount oil filter header OILFILTER, canister remote mount OILLINES. The oil filter bypass is located at the bottom of the remote mount oil filter header. If the oil filter becomes plugged or if the oil line become restricted, the oil will pass through this bypass to feed unfiltered lube oil to the engine. To accommodate the relocated oil filter, there is a redesigned oil filter fuel filter assembly bolted to the oil cooler. This oil filter header has 2 access holes for oil lines to transport oil to the oil filter housing at the left rear of the engine upper oil pan. Since the space is limited on the Econoline chassis, the oil filter housing has been relocated to left rear corner of the engine's upper oil pan. Steel lines are used to route oil to the remote-mounted oil filter. Oil filter bypass, remote mount oil filter header, fuel filter housing, remote mount oil lines. Econoline lubrication system 74757338, oil filter bypass VALVEOILFILTER bypass valve filtered OILFILTERED oil unfiltered OILUNFILTERED oil unfiltered OILUNFILTERED oil filtered OILFILTERED oil to OILFILTERTO OILFILTERTENGINETO engine. The oil line is routed down the right rear of the engine, staying clear of the IPR valve, and under the right side exhaust up pipe. The oil line enters the oil filter housing near the outside edge of the housing. Clean oil exits through the top, center of the oil filter housing. The clean oil line returns to the oil filter header, where the oil will be distributed to the engine lube system and the high-pressure oil reservoir. Note: the remote mount oil filter lines must be removed in order to remove the turbocharger mounting bracket. As the oil line leaves the oil filter header, it drops down and passes under the turbocharger mounting bracket. As the oil line reaches the rear of the engine, it rises over the high-pressure pump cover. The oil lines have been positioned toward the center of the high-pressure pump cover in order to avoid restricting access to the IPR, injection pressure regulator, valve. Oil line routing. Rear oil line routing. Engine Valley Econoline Lubrication System 777639 filtered oil from OILFILTER assembly filtered OILFROM OILFILTER assembly unfiltered oil from OILPUMP unfiltered oil from OILPUMP unfiltered oil from OILPUMP unfiltered oil from OILPUMP filtered oil from OILFILTER filtered oil from OILFILTER OILFILTER ASSEMBLY OILFILTER assembly. The fuel filter housing has been modified to accommodate the Econoline chassis. The regulator has been repositioned to provide accessibility in chassis. The fuel supply line now has a banjo bolt with 2 copper washers connecting it to the fuel filter housing. Engine fuel system flow fuel filter housing Econoline FUELSYSTEM 797840 fuel supply line fuel return LINE FUELRETURN line FUELREGULATOR FUELREGULATOR banjo BOLTBANJO bolt FUELRETURN to tank FUELINLET check valves SECONDARY FUELFILTER housing FUELSUPPLY from pump. The engine serial number is now located on the external crankcase breather. The FICM has been relocated by the brake booster on the Econoline chassis. Oil fill tube adapter is now pointed to the front of the engine for accessibility. The glow plug harness has been lengthened on the Econoline chassis to increase accessibility to the harness connector. The location of the ICP sensor is the same as on the F series. The EP, exhaust pressure, sensor and tube have been repositioned to adapt for the chassis. The GPCM bracket has been relocated to the left valve cover. The GPCM, EP sensor, and power junction point all share a common stamped steel mounting bracket. The mounting bracket is also utilized to secure the compressor inlet hose. Econoline 6.0 LDIESELENGINE engine serial number chassis mounted FICM oil fill adapter glow plug connector ICP sensor EP sensor GPCM 82808141 ICP sensor EP sensor EP sensor GPCM engine serial number EXTERNALCRANKCASEBREATHEREXTERNALCRANKCASE breather OILFILLADAPTER OILFILLADAPTER glow plug CONNECTORGLOW plug connector BATTERYPOWER junction point BATTERYPOWER junction point. Notes 42. The information in this section is not intended to replace any portion of the Ford Motor Company service manual, but should be used in conjunction. Please see Ford Motor Company service manual for complete diagnostic and test procedures. Diagnostic procedures and service tips powerstroke DIESELDIAGNOSTICS no start diagnostics fuel and oil ICP test CKP trigger wheel test ICP block off tools cylinder balance diagnostic procedures and service tips no start diagnostics. This procedure is a method to diagnose an engine crank, no start condition and to describe what is required for a 6.0 L diesel engine to start. With the WDS, access the data logger screen. Highlight PIDs listed below. Before cranking the engine, hook up a mechanical fuel pressure gauge to the diagnostic port located on the secondary fuel filter housing. Monitor fuel pressure and the highlighted PIDs to determine the cause of the no start concern. VPWR battery power. If low voltage condition is present, check battery, charging system, or power GND circuits to the PCM. FICM LPWR FICM logic power. No, low voltage indicated could be caused by the 12-way connector or logic power fuse. Refer to pinpoint S for detailed 12-way con. Diagnostics. FICM VPWR no or low voltage indicated could be caused by 12-way connector or the key power circuit. Voltage drop from the battery to the FICM should not exceed a 2 to 5% difference. RPM low RPM can be caused by starting charging system issues. No RPM indicated while cranking could be CKP fault. ICP a minimum of 500 psi 3.5 millipascals is required for the injectors to be enabled. No or low oil in the HP system or reservoir, system leakage, faulty IPR, or high pressure pump could cause low pressure. IPR duty cycle typically will increase to 80 to 84% within a couple of seconds off starting, defaults to 14% 300 psi with OCKP signal. ICP voltage. Voltage reading below spec indicates low ICP during crank. FUELPW fuel pulse width. Pulse width defaults to 0 with OCKP signal, RPM below minimum spec, or low ICP. FICM SYNC. No FICM sync could be caused by the PCM, FICM, or engine wiring harness. Sync. No sync could be caused by CKP, CMP faults, PCM, or engine wiring harness. Parameter specification measurement VPOWER8 VOLTMIN. FICM LPOWER8 VOLTMIN. FICM VPOWER8 VOLTMIN. RPM 100 RPM min. ICP PRESSURE 500 PSI 3.5 mPa ICP VOLTAGE 0.80 volts min. FUELPW 500 US 2 millisiemens FICM SYNCYES no SYNCYES no FUELPRESSURE 45 Psi min. Note: these specifications are minimum values. A minimum value may result in an extended crank time. 8243. Note: if the FICM has been replaced with a service part, it will need to be programmed. The service part does not come programmed. The injectors will not rattle when the key is cycled until the FICM has been successfully programmed. No start diagnostics 44. Diagnosing FICM logic power. Note: if there is no FICM logic power to the FICM, the injectors will still buzz once the key is cycled but the engine will not start. There will be no other symptoms related to a no start condition. With the WDS, select Datalogger PID FICM LPWR. This PID will show how much voltage is being supplied to the FICM. If less than 8 volts, check for short, open or low battery. If no voltage is being supplied, check logic power fuse located in the relay center box. This box is mounted on the driver's side towards the firewall. No voltage could also be caused by the FICM logic circuit through the 12-way connector. Sync. Sync is achieved when the PCM receives a signal from the crankshaft sensor and camshaft sensor indicating they are working in time. If the crankshaft and camshaft sensors are working improperly, the PCM cannot calculate engine speed or cylinder position, preventing fuel delivery. Diagnosing sync. No sync with an RPM signal typically is a faulty CMP sensor circuit problem. No sync and no RPM signal typically is a faulty CKP sensor circuit problem. PCM Powertrain Control Module CMP CKP FICM Logic FUSE FICM Logic Fuse 8384. No start diagnostics 45 FICM sync. The FICM uses CMPO camshaft position sensor output and CKPO crankshaft position sensor output signals, which are sent by the PCM, to calculate FICM sync. FICM sync is calculated by the FICM and is the correlation between the camshaft pin and the crankshaft triggers. Once FICM sync is achieved, the FICM uses engine speed, MFDES mass fuel desired, EOT, and ICP to calculate fuel timing, pulse width, and pilot injection usage. Diagnosing FICM sync. If there is no FICM sync while cranking the engine, then the problem is limited to the circuit illustrated above. The FICM sync circuit relays information from the PCM to the FICM. Engine wiring harness. FICM sync occurs through two circuits between the FICM and PCM. Verify engine wiring harness circuits CMPO and CKPO. If one of these two circuits has a short open, FICM sync will not occur. PCM. If the PCM is not working properly, FICM sync may not occur. FICM. If the FICM is not working properly, FICM sync may not occur. PCM Powertrain Control Module FICM Fuel Injection Control Module CKPO CMPO Fuel Pressure. There must be an adequate amount of fuel flow and fuel pressure present before the engine will start. Areas listed below can cause low fuel pressure flow. Faulty fuel pump, pinched, clogged fuel lines, broken, clogged banjo bolt, clogged fuel filters, aerated fuel. Fuel quality should also be examined for a possible no start condition. Air inlet and exhaust restrictions. Be aware of air inlet or exhaust restrictions. If necessary, eliminate these possibilities by removing the charge air cooler pipe hose from the intake manifold inlet and the exhaust down pipe from the turbine side of the turbo, for testing purpose only. FUELPRESSUREADAPTORFUELPRESSURE adapter air cooler pipe removed from intake manifold air cooler pipe removed from intake manifold exhaust down pipe REMOVEDEXHAUST down pipe removed 8687. Fuel and OILDIANOSTIC procedure 46 issue cause. Some vehicles equipped with the 6.0L diesel engine may exhibit diluted oil. Runs rough and or low power. This may be caused by fuel leaking into the engine from the injectors. Note: this procedure MUSTBE followed COMPLETELYANDEXACTLYAS written. Failure to do so MAYRESULTIN misdiagnosis, incomplete repair ORUNNECESSARYPARTREPLACEMENT. Before starting the engine, check engine oil level on dipstick. If the oil level is above max, due to dilution with diesel fuel, the oil will appear thin and watery. Due to the design of the dipstick, it may be difficult to use for confirming an overfull condition. If an overfull condition is suspected, insert a clean dipstick leaving it 1 inch above the seated position. Remove the dipstick and check the oil level. Continue this process, leaving the dipstick 1 inch higher each time. If the oil level is determined to be overfull, pull the drain plug and let the oil fuel drain out until it stops dripping. Be sure to also drain the oil filter housing. Measure the amount of fluid drained from the crankcase. Note: for 6.0L powerstroke diesel engines with engine oil diluted with 4 or more quarts of diesel fuel, the turbocharger endplay needs to be checked. 0.001, 0.004, allowable. Also check radial shaft movement by lifting the shaft up and rotating the shaft to check for compressor or turbine wheel housing contact. If any wheel contact is noticed, the turbocharger must be replaced. Check the PCM for cylinder contribution balance diagnostic trouble codes DTCs. Diagnose cylinder contribution balance DTCs per pinpoint test P15. Cylinder contribution balance DTCs will not be set for all injector-related concerns resulting in fuel dilution. Continue with remaining steps. Block the fuel line to the left head at the fuel filter housing. To do this, remove the fuel line from the connection point at the secondary fuel filter housing. Remove the brass adapter that is screwed into the filter housing. Remove the fuel pressure test port plug from the front of the secondary fuel filter housing. Install the plug in the left bank outlet port. The fuel pressure adapter number 303 to 765 and fuel pressure gauge should be installed at the test port in order to confirm constant pressure. Run the fuel pump using WDS active commands in order to maintain constant pressure. Watch for fuel to drain out of the oil pan drain hole. Depending on the severity of the leak, it may take some time to leak enough fuel to run down to the pan. Allow the fuel pump to run for up to 10 minutes. It is possible that the leak indication may not occur when the engine is cold-cool. If this is the case, it will be necessary to perform the leak test on a warm engine. The block heater may be used to increase the coolant temperature to induce the leak if necessary in the case where the engine cannot be idled to warm up prior to leak evaluation. Right head leak test setup. Right head leak test setup. FUELPRESSURE test port PLUG. FUELPRESSURE test port plug brass ADAPTORSBRASS adapters left bank. FUELLINE left bank. FUELLINE right bank. FUELLINE RIGHT bank. FUELLINE test port PLUG TEST port plug left bank. FUELLINE left bank. FUELLINE FUELPRESSUREADAPTORFUELPRESSURE adapter DIESELFUELIN engine OILDIAGNOSTICS 8889. Fuel in oil DIANOSTIC procedure. Left head leak test setup. Left head leak test setup. Right bank fuel line. Test port plug. Fuel pressure adapter. 90. If fuel is present, suspect at least one injector or injector O-ring leaking in the right head. Turn off the fuel pump at this time. Reverse the test at this time, blocking the right bank fuel line at the fuel filter housing. Use the same procedure as described in step 3. Move the plug from the left supply port to the right bank supply port. It may also be necessary to loosen or remove the fuel line retaining bolt secured to the front of the intake manifold. Run the fuel pump using WDS, active commands. Watch for fuel to drain out of the oil pan drain hole. Depending on the severity of the leak, it may take some time to leak enough fuel to run down to the pan. Allow the fuel pump to run for up to 10 minutes. If fuel is present, suspect at least one injector or injector O-ring is leaking in the left head. Turn off the fuel pump at this time. Reconnect the fuel line. Remove the appropriate valve cover S. If a fuel leak was not identified on the right or left bank, remove both valve covers for additional inspection. Remove the high-pressure oil rail. Check the torque of each injector hold-down bolt. Refer to the Workshop Manual Section 300-304D for torque specifications. If an injector is found loose, remove the injector. Inspect the injector body O-rings, and copper washer at injector tip for damage. Replace as necessary. Caution: installation and removal of an injector should not be completed with air power tools. Excessive speed can damage the injector O-rings. Clean the top of the head with brake clean and dry it thoroughly, especially on the downside of each injector. Turn on the fuel pump. Inspect injector body O-ring area. Look carefully to see if fuel is leaking from the small weep hole just above the top injector body O-ring. Use a mirror to help look for fuel leaking from individual injectors. If a leak is not detected within 5 minutes, install 1 ounce of oil dye and continue your inspections. Note: adding 1 ounce of oil dye to the fuel filter housing in conjunction with use of a black light may aid in identifying the fuel leak. If fuel is observed leaking from the injector body O-ring area, replace the 2 injector body O-rings. If fuel is leaking from the small weep hole just above the top injector body O-ring, replace the injector. Caution: installation and removal of an injector should not be completed with air power tools. Excessive speed can damage the injector O-rings. Following any repair, retest to confirm repair. Check the charge air cooler CAC for fuel and/or oil. Clean the CAC and air dry with shop air thoroughly before reinstalling. Reinstall the oil pan drain plug. Refill engine with oil and change oil filter. Drive vehicle approximately 20 miles. Change engine oil and filter. Be sure to drain the oil out of the oil filter housing. Repeat final steps, maximum of 2 engine oil flushes. 47. High pressure oil diagnostics. High pressure oil leak diagnostic procedure. Symptoms: drivability, runs rough, stalls, no start when hot. DTCs P2284, P2290 or P2291. 6.0L diesel engine, high pressure oil system diagnostics. Verify nature of concern. Verify lube oil supply pressure. If the nature of the concern exists, hot only, hot no starts, safely bring the vehicle up to necessary temperature range. Monitor IPR, injection pressure regulator, duty cycle as engine oil temperature increases. A high pressure oil leak should be indicated by a rising IPR duty cycle. As EOT increases and the leak rate increases, ICP pressure can begin to drop as the IPR is no longer capable of compensating. Check the operation of the IPR valve. Remove one of the valve covers from the engine. Apply shop air pressure to the high pressure rail using special tool adapter number 303 to 766. When the air pressure is applied, there will be a noticeable air leak due to the IPR valve being in an open state. With the WDS, increase the duty cycle of the IPR valve. This should block that air leak. If no change is heard, the IPR valve is not functioning as commanded. Your concern could be the IPR valve or the PCM to IPR circuit. If a change in the air leak is heard, the IPR valve is operating and investigation for the high pressure oil leak begins. With the IPR blocking the air leak to the oil pan, listen for the position of the air leak in the engine. A stethoscope can improve your ability to narrow down the location of the leak. Air hose fitting. Tool number 303 to 766. Note: air may leak past the high pressure oil pump shaft seal. This is normal and does not require pump replacement. The leak can exist in the following areas: early model, cracked broken check valve and fitting in high pressure oil rail, under either valve covers, disconnected high pressure hoses under valve covers, stand pipe from high pressure hose to the branch tube in the tappet gallery, O-ring at the bottom could be cut, torn or missing, wavy rail, O-rings on the top and bottom of each stand pipe and or all 4 plugs in the high pressure rail. All models. O-ring in between discharge tube and high pressure pump. O-ring around discharge tube that fits inside high pressure pump cover. High pressure pump inlet O-ring. Branch tube from high pressure pump to stand pipe in the tappet gallery. High pressure oil injector O-ring. High pressure rail connects to the injector. 91. 48. Crankshaft timing wheel. Bent damaged crankshaft trigger wheel. Symptoms. This procedure is intended to identify a bent damaged crankshaft trigger wheel. The most common symptom is a rough idle. The engine oil temperature does not affect the rough idle concern. Diagnostics. Assure there are no codes present. If there are any codes, repair is necessary before continuing with the following procedure. Start engine and verify rough idle concern. Slightly accelerate engine off of idle. Does the engine smooth out? If it does, proceed with the following diagnostics. Using WDS World Diagnostic System, monitor power balance. Typically there are two injectors indicating weak cylinders. These two injectors will be 180 degrees off in firing order. Firing order is 1, 2, 7, 3, 4, 5, 6, 8. For example, number 3 and number 8 will indicate weak cylinders. Perform a mass fuel desire test to verify these injectors are contributing correctly. If they indicate no problem found, select number 1 INJ PID. With the solid border surrounding the PID, enable active command control for injector cancel. Take control of the active command but do not toggle, plus or minus, to disable cancel the injector. Notice the idle quality while performing this function. If the engine smooths out, this is a good indication of a bent trigger wheel. Verify. To verify the crankshaft trigger wheel is damaged, follow the procedure below. Disconnect battery cables. Drain oil out of oil pan. Remove both turbocharger cooler pipes. Remove the radiator stator shroud. Loosen engine mount bolts from chassis. Lift engine off of chassis until turbo is against the heat shield on the cowl. Remove all the oil pan bolts. Drop oil pan down to remove bolts in the pickup tube. Remove the oil pan by backing it out towards the transmission. The crankshaft trigger wheel is located at the front of the crankshaft. Manually turn engine over while inspecting every tooth on the trigger wheel. If there is any visual damage to the teeth, see example below. Contact the Ford Technical Service hotline for instructions. Damaged tooth. 92. Damaged teeth. 93. 49. 97. The solid block-off tool is used in the left bank high-pressure oil rail only. It enables you to eliminate the left high-pressure oil rail and the left bank injectors while testing the integrity of the remaining high-pressure oil system. ICP pressure is measured using the ICP sensor installed in the right bank high-pressure oil rail or the right bank block-off tool. Note: both block-off tools can be used at the same time to eliminate both high-pressure oil rails and all 8 injectors. ICP pressure voltage will be monitored using the ICP sensor installed in the right bank block-off tool, the ICP breakout harness, as pictured above, and the WDS. This block-off tool is used on the right bank only. The ICP sensor breakout harness tool number 418D003 is utilized to extend the reach of the wiring harness so pressure voltage can be read using the WDS. This tool will enable you to eliminate the right bank high pressure rail and injectors while testing the integrity of the remaining high pressure oil system. To utilize the tool properly, the ICP sensor is removed from the high pressure oil rail and is placed in the block off tool. Left bank block off tool, right bank block off with ICP sensor, ICP BLOCK off tools 50 breakout HARNESSBREAK out harness block off TOOL BLOCK off tool 95 94 96. Cylinder balance test 51 cylinder balance test. Before using cylinder balance test, performance diagnostic routines should be followed to ensure no other performance concerns are present. Cylinder balance test measures the increase of engine RPM during each firing cycle. The test then compares the RPM contribution of each individual cylinder to determine a weak cylinder. When performing cylinder balance, you should use the following procedure. Using WDS, connect to the vehicle and perform a POWERBALANCETEST. With power balance still running, switch to data logger and select an injector PID 1 to 8, it doesn't matter which one. Highlight the injector PID and take active command of the PID. Do not shut the injector off. The FICM has a fuel correction feature that is used to smooth idle operation by adding fuel to any cylinder that lowers engine speed during a firing cycle. Following these steps will disable the FICM's fuel correction feature. Taking active command of an injector will cause all 8 injectors to use a baseline fuel rate. Using the tabs at the top of the screen, switch back to the power balance and look for any injector that falls below 15 rpm. If a cylinder drops below 15 rpm, perform an injector electrical stand a relative compression testo check for base engine problems. If no other problems are found, replace the injector for the indicated cylinder. Note: active command will only disable fuel correction for about 1 minute. Cylinder balance test 9899 power balance test active command datalogger number 1 injector still in. Notes 52. Torque charts, 0.54 hard start, no start diagnostics, 0.58 performance diagnostics, 0.59 wiring diagrams F series, single alt, 0.60 F series dual alt, 0.62 Econoline, single alt, 0.64 Econoline, dual alt, 0.66 diagnostic codes, 0.68 glossary, 0.72 index, 0.75 appendix 53 table of contents. SPECIALTORQUE chart 54 COMPONENTSTANDARDMETRIC air inlet duct clamp, 0.44 lbf, in 5 Nm camshaft follower retaining device bolt, 0.10 lbf per foot 13 Nm camshaft position, CMP, sensor, 0.96 lbf, in 11 Nm camshaft thrust plate mounting bolts, 0.23 lbf per foot 31 Nm connecting rod bolt, initial 0.33 lbf per foot 45 Nm final 0.50 lbf per foot 68 Nm coolant block heater, 0.30 lbf per foot 41 Nm crankcase breather, 0.62 lbf, in 7 Nm crankcase plug, M16, 0.15 lbf per foot 20 Nm crankshaft position, CKP, sensor, 0.96 lbf, in 11 Nm cylinder head bolts, see Figure A, Figure A EGR cooler coolant supply port cover, on oil filter base, M6.89 lbf, in 10 Nm Egger cooler V-band clamp, 0.48 lbf, in 6 Nm EGR cooler flange, studs, C note 1.10 lbf per foot 13 Nm EGR cooler support, C note 1.23 lbf per foot 31 Nm EGR valve mounting bolts, 0.10 lbf per foot 13 Nm engine coolant temperature sensor, ECT, 0.108 lbf, in 12 Nm engine oil pressure switch, EOP, 0.108 lbf, in 12 Nm exhaust manifold flange to up pipe, C note 2.20 lbf per foot 27 Nm exhaust manifold, C note 2.28 lbf per foot 38 Nm exhaust pressure, EP, sensor bracket, 0.106 lbf, in 12 Nm exhaust pressure, EP, sensor, 0.108 lbf, in 12 Nm exhaust pressure, EP, tube nuts, C note 2.11 lbf per foot 15 Nm exhaust up pipe coupling on right side, 0.20 lbf per foot 27 Nm flywheel bolts, see Figure B, 0.69 lbf per foot 94 Nm front cover module bolts, 0.18 lbf per foot 24 Nm fuel check valve banjo bolt, 0.28 lbf per foot 38 Nm fuel filter supply and return lines, 0.32 lbf per foot 43 Nm fuel filter supply to head lines, 0.19 lbf per foot 26 Nm fuel injector hold down, 0.24 lbf per foot 33 Nm fuel rail plug, rear of head, 0.20 lbf per foot 27 Nm fuel supply line banjo bolt, Econoline only, 0.26 lbf per foot 35 Nm glow plug, 0.14 lbf per foot 19 Nm glow plug control module, GPCM, 0.71 lbf, in 8 Nm heat shield for intake manifold, M6 nut, 0.96 lbf, in 11 Nm heat shield bolts for rear, M6 thread forming, 0.96 lbf, in 11 Nm, M10.36 lbf per foot 49 Nm high pressure discharge tube mounting bolts, 0.71 lbf, in 8 Nm high pressure rail front port plug, 0.60 lbf per foot 82 Nm high pressure rail supply port plug, 0.60 lbf per foot 82 Newton meters high pressure oil rail plug M14 0.33 lbf per foot 45 Newton meters M8.96 lbf in 11 Newton meters high pressure oil rail bolt see figure C 0.120 lbf in 14 Newton meters high pressure pump cover bolts 0.96 lbf in 11 Newton meters high pressure pump cover plug 0.26 lbf per foot 35 Newton meters high pressure pump drive gear bolt 0.95 lbf per foot 129 Newton meters high pressure pump mounting bolts 0.18 lbf per foot 24 Nm injection control pressure ICP sensor 0.108 lbf in 12 Newton meters injection pressure regulator IPR 0.37 lbf per foot 50 Newton meters intake air temperature 2 IAT2 sensor 0.13 lbf per foot 18 Newton meters intake manifold see figure D 0.96 lbf in 11 Newton meters lifting eye bolts 0.30 lbf per foot 41 Newton meters lower crankcase main bolts see figure E figure a lower crankcase outer bolts M8.18 lbf in 24 Newton meters SPECIALTORQUE chart 55 COMPONENTSTANDARDMETRIC torque chart notes 1 Titan 2 M6 studs in front EGR cooler flange first then install M8 EGR cooler support bolt 2. Apply high temperature nickel anti-seize lubricant F6AZ9L494AA to threads of bolts prior to assembly. 3. Lightly coat O-ring with engine oil before installing. 4. Apply threadlock 262 to bolt threads prior to assembly. 5. Tighten bolts across center of crankshaft. Standard torque chart hex flange head thread torque wrench diameter BF FTNM size M6X 18118 M8 by 1.25182410 M10 by 1.53649113 M12 by 1.75618315 M16X 215420821 hex head M6X 16810 M8 by 1.25152013 M10 by 1.53040116 M12 by 1.75516918 M16X 212817324 pipe thread 1/8 NPT 710.21 quarter NPT 1013.63 NPT 1520.41 half NPT 2534.03 quarters NPT 3040.8 oil cooler mounting bolts M8.16 lbf per foot 22 Newton meters M6.89 lbf in 10 Newton meters oil filter cap 0.18 lbf per foot 24 Nm oil filter drain Econoline only 0.7-8 lbf per foot 10 Newton meters oil filter housing bolts 0.11 lbf per foot 15 Newton meters oil filter stand pipe bolt new 0.53 lbf in 6 Newton meters reinstallation 0.27 lbf in 3 Newton meters oil pan drain plug see note 3.18 lbf per foot 25 Newton meters oil pickup tube flange bolts 0.18 lbf per foot 24 Nm oil pump housing bolts 0.72 lbf in 8 Newton meters oil pressure regulator plug 0.19-21 lbf per foot 26 to 29 Nm piston cooling jet C note 4.10 lbf per foot 13 Newton meters rocker arm fulcrum bolts 0.23 lbf per foot 31 Newton meters water pump bolts M8.17 lbf per foot 23 Nm water pump plugs 0.26-28 lbf per foot 35 to 38 Nm water pump pulley bolts 0.23 lbf per foot 31 Newton meters thermostat housing bolts 0.17 lbf per foot 23 Nm turbo exhaust adapter V-band clamp 0.108 lbf in 12 Newton meters turbo oil supply bolts 0.18 lbf per foot 24 Nm turbo oil supply line flange retaining bolt 0.7 lbf per foot 10 Newton meters turbo to mounting bracket bolts C note 2.23 lbf per foot 31 Newton meters turbo bracket to crankcase mounting bolts 0.23 lbf per foot 31 Newton meters valve cover bolts 0.72 lbf in 9 Newton meters vibration damper C note 5 initial 0.50 lbf per foot 68 Newton meters final additional 90 degrees rotation only use new bolts Once these bolts have been loaded to the initial value, do not reuse. All figures on next page. Special torque chart. Cylinder head bolts. Note: once bolts have been loaded to the initial value, they may not be reused. Use only new bolts. 15. 13. Intake side. 11. 12. 14. Step 1. Torque the M14 1 to 10 cylinder head bolts to 65 lbf per foot 88 Newton meters in the numerical sequence shown. Step 2. Torque the M14 cylinder head bolts 1, 3, 5, 7, and 9 to 85 lbf per foot 115 Newton meters in the numerical sequence shown. Step 3. Tighten the M14 cylinder head bolts an additional 90 clockwise in the numerical sequence shown. 9, 10, 5, 1, 3, 7, 6, 2. Exhaust side. Figure A. 4. Step 4. Tighten the M14 cylinder head bolts an additional 90 clockwise in the numerical sequence shown. Step 5. Tighten the M14 cylinder head bolts an additional 90 clockwise in the numerical sequence shown. Step 6. Torque the M8 11 to 15 cylinder head bolts to 18 lbf per foot 24 Newton meters in the numerical sequence shown. Final step. Torque the M8 cylinder head bolts to 23 lbf per foot 31 Newton meters in the numerical sequence shown. Flywheel bolts. Note: once bolts have been loaded to the initial value, they may not be reused. Use only new bolts. Step 1. Torque the bolts to 1 to 5 lbf per foot 1.4-7 Newton meters in the numerical sequence shown above. 7. 1. 9. Final step. Torque the bolts to 69 lbf per foot 94 Newton meters in the numerical sequence shown above. 6. 8. 2. 5. 10. 8. 3. 4. Figure B. Intake manifold bolts. Step 1. Install bolts 1 through 8 finger tight. Step 2. Torque bolts 9 through 16 to 8 lbf per foot 11 Newton meters. Final step. Torque all bolts to 8 lbf per foot 11 Newton meters in the numerical sequence shown. 5, 1, 3, 2, 4, 7, 6, 8, 16, 14, 15, 12, 13. Figure D. 10, 9, 56, 11. Special torque chart. Wavy high pressure oil rail installation and torque procedure. 3, 1, 2, 4, 1, 5, 9, 7, 3. Figure C. Front of engine. 20, 19, 17, 12. 11, 10, 4, 3, 2, 18, 9, 1, 2, 6, 5, 14, 13, 7, 15, 8, 16. Bottom view. Figure E. 6, 8. Step 1. Place the oil rail on top of the carrier so that the 4 single ball tubes are engaging the injector lead angle. Step 2. Insert 3 guide bolts, 2 on the ends of the straight side of the oil rail and 1 in the middle of the wavy side of the oil rail. See figure to the left. Step 3. After the 3 guide bolts are threaded in 6 or 7 turns, press the rail into the injectors. Step 4. Once the oil rail has completely engaged the injectors, the oil rail mounting feet should be flat against the carrier mounting surfaces. Now insert the remaining 6 bolts. Step 5. Turn all 9 bolts until snug. Step 6. Torque all bolts to 120 N per pound. Starting with the center bolt on the wavy side of the oil rail. Follow sequence shown in Figure C. Main bearing bolts. Note: bolts must contain a light film of oil on the bearing surface under the head and threads prior to assembly. Step 1. Torque the bolts to 110 lbf per foot 149 Newton meters in the numerical sequence shown. Step 2. Torque the bolts to 130 lbf per foot 176 Newton meters in the numerical sequence shown. Final step. Torque the bolts to 170 lbf per foot 231 Newton meters in the numerical sequence shown. 57. 58 Hard start no start diagnostics Wallangerts, Fu 12 BDP 12A 650 Etikagstakshioy. List part name, number and serial number of parts replaced. 7. Perform KOEO on demand self-test 11. Glow plug system operation, use a scan tool. DTC Sittering Thysistaricurrent faults GPSIM operation diagnostic, a tour and trouble fuel oil cocalhos leaks 8. Retrieve continuous VV trouble Cody's method check, use its scan tool. Onedlif of visual DDCs rev during this test air historical faults, using ANCO DDCs. If 2. Check engine oil level trouble codes IFYFF. Check for contaminants fuel, coolant. 0.9. KOEO injector electrical self-test click test using XMNDiotbids, verify COBI. Inject spend.ug level. Orswilwil elt on, time, method check pararianti visual injectorale and time spec, measurement tray 1 to 120B plus IEVD, go to appropriate PPT test. T in Legix. 10. Scan tway to start lamium GP, on, time, inspectem. Scan to bell 9.5 LTS. Titlo plug resistance IFR for ender indicator has been illuminated. Select TFR the scan tool. Thepenco cover check parametringya. OU visual par measurement. Nahar V power glow plug harness to CL5 CML power 8 volt min. Plug town door tine fuel amphas bean 5 CMV power number to 2 ohms zeros TRPM 100 RPM number 1 after vein head ank. Drain a minimum number 3 EE. ICP 3.5 ampaman. Number 5 set recommended for number 7 optimum start. ICP volts 0.80 Vmin. Number 2 method check FWELP 500 US 2 Ms. Number 4 visual fee. Number 6 APWRI voltage quantity is end. Check battery. Number 8 5. Electric fuel pump pressure ecarging syst, or power GND circuits to THEPCM. Verify TFF hat thefwell pump voltage end. Keon. BFI CMLPWR no low volt indicated cold because E serene ferengway or Qs. Refernostics EC Phi CMV pulled because W measurement D chargi 0 to 160 psi 45 simin. System indicated cranking cold B gauge B if pressure fails low go to next step to verify no restriction PSI 3.5 A RNSTEM measure or restrictiaplet. High instrument measurement add 5 GL plan time ween above 0, HG 6 SIL 0.7000 feet vacuum Phi CP spec indicate slow ICP, if greater than 6 inches HG restriction, check lines between pump and fuel tank. Duric IFRs, if sir okay, check fuel GTO O CKP regulator IFR and filter replace fuel pump. CM Cinecycle BEP faults. Refer to PC Ed Section 4 for detailed test procedures. 1 to 8. 020 40 60 80 100 120 140 020 40 60 100 120 140 EOT at FF time seconds. Note: a hard start, no start concern with EOT TE. Customer name F Series Excursion Econoline Powerstroke 2004.25 Model Year 6.0 L Powerstroke Diesel Engine Diagnostic Guide Chassis STYLELL Customer concerns please list in this box dealer name 1863 claim NUMBERDATE engine serial NUMBERODOMETER type of service vehicle GVWTRANSMISSIONAMBIENT temperature PERSONALCOMMERCIAL and a code NOTEIF concern is found, service is required. If this corrects the condition, it is not necessary to complete the remainder of the diagnostic procedure. See Ford's PTS Professional Technicane Society website for latest information. 59 Performance Diagnostics Wallangerts, FU 12 BDP 12A 650 Etikagstikshioi. List part name, number and serial number of parts replaced. 8. EG12A. Lope verify Tiefnoleaks. Pernef, F. Low, F. Lee, Usem Stata Control Forager, Monotopwi. Inspect MAFOs, intercooler hose, anti-M folds for leaks, monitor agar positions in sorpid and calculate travel, parameter spec. At 670 RPM measurement fuel coolant electrical hose leaks instrument spec. Cent actual percentic P 4.5 minus 5.5 M plus 0.3 megapascals CHECKSCANTOOL 1.2 volts. Visual CL underscore, blank, underscore closed take a treading BCP if engineer misunstable, discore ICP will default. CL 90% if RPM is still unstable, and go to 12B. Bean illuminated. 0.52 V blank, underscore open if RPM SM sensor is at fault. Dang. Openest, set 50 Minded for check at low idle, above 70 C, 158 F, optimum performance 90% and 3.2 V underscore, blank, underscore travel, M-scan tool. Travel measurement method check, repair issue causing out of speed continuing 0.30% max visual 9. Exhaust restriction, if duty cycle is below max spec go to next step. V exhaust system damage, IFEC, check for system leak with 3. LMT scan TNET meta procedure in hard start NA start fuel, coolant minimum cert car tubes connections, turbocharger MTL evil. EP 244 kp or signs of damajor leaks. Check MaxP. Visual 10A. Electric fuel pump pressure MPTH tool. Measure of fuel pressure rate engine filtered housing test port. Road test select appropriate gear tube station desired engine 4. Coio demand test road test engine full load conditions pedan full load on engine climbing hiller loaded truck. U measurement 500th test are current faults. 0-1.1 MPa 310-379 kilopascals IC 0 to 160 psi 45 to 55 psi minimum. Parameter measurement ERT codes MGP5 sees if fuel pressure fails low, go to step 10B. If test fails low, inspect turbo blades for damage. Use its scan tool. If pressure is above spec, check fuel return lines for restriction. Detrievingis tear historical faults. If no restriction is present, replace fuel pressure regulator valve. Est meter trouble codes measure a restriction at fuelplit. P170 F NIM. 6. KOEO injector electrical self-test instrument spec. Measurement BL valve cover. U 6 inches HG max with no load at 3000 RPM. Aerolilik, the individual measurement in 1 iPhone, check lines between pump and fuel tank. 0.8 inches H squared max injector, IFRIFs are OK, check fuelic trouble code air, IFR and filterup. If Mo T8 squared L, if self-test codes are retrieved, go to appropriate PPT. 10C. Fuel aeration test 15. Oil aeration test 7. Intake restriction, install clear hose and fuel return at fuel control module. Run engine at 3000 RPM for 1 minute. Procedure. Take oil for theoch title. Let's run fuel be free of bubbles. At check method heck instrument spec. Check visual MLIC, if air is prayer for leaks. Filter minder 2 inches minus 25 inches H squared 011. Co-on-demand test, excessive oil aeration can be caused by depleted oil additives. This will tick B, E grand EVGD performance, pickup tube leak, front cover seal leak, or upper pan seal leak. Core note. If Piermanos concern still exists, refer to Enhanced Injector DTCTH. Econoline Customer Name F-Series Excursion Econoline PowerStroke 2004.25 Model Year 6.0L PowerStroke Diesel Engine Diagnostic Guide Chassis STYLELL Customer Concerns Please list in this box Dealer Name 1863 Claim NUMBERDATE Engine Serial NUMBERODOMETER Type of Service Vehicle GVWTRANSMISSIONAMBIENT Temperature PERSONALCOMMERCIALP and a code NOTEIF Concern is found, service is required. If this corrects the condition, it is not necessary to complete the remainder of the diagnostic procedure. See Ford's PTS Professional Technicane Society website for latest information. 60 F Series Single Alt. '61 F Series Single Alt. 24-way transmission connector A C clutch plus A C clutch. Key power V power. 62 F Series DUALALT. '67 Econoline DUALALT. Backup lamp relay control LHBKP. Diagnostic codes P0046C or turbo, supercharger boost control solenoid circuit range performance internal to PCM. VG actuator circuit check. Diagnostic circuit associated with 1 amp driver checks for open circuit, short to ground, and short to power. P0069C map borrow correlation 30 kilopascals 4.4 psi compares B-pand map at idle. VGT, BP, map, EGR, system fault, biased sensor, circuit integrity. P0096C intake air temperature sensor 2 circuit range performance 5 deg, C41 deg. F checks for minimum change in IAT2 biased sensor, system fault, PCM. P0097C or intake air temperature sensor 2 circuit low input trigger disabled, less than 0.15 volts. Mat signal circuit, shorted to ground or defective sensor. P0098C or intake air temperature sensor 2 circuit high input trigger disabled, greater than 4.8 volts. Mat signal circuit, open, short to power or defective sensor. P0101C mass or volume air flow circuit range performance indicates a MAF range performance problem was detected during normal driving conditions when MAF is enabled. 4.0 volts when RPM is less than 1500, 4.9 volts when RPM is greater than 1500 RPM. Damaged MAF sensor plugged or restricted sensor supply tube MIF, PCM. P0102CR mass or volume air flow circuit low input indicates MAF sensor circuit low input was detected during KOEO self-test or during continuous diagnostic monitoring. MAF voltage less than 0.35 volts. Open MAF sensor circuit biased sensor, PCM short to sign RTN or PWRGND on MAF sensor circuit open in VREF circuit. P0103C ORMUS or volume air flow circuit high input indicates MAF sensor circuit high input detected during KOEO on demand self-test or during continuous diagnostic monitoring. MAF voltage is greater than 4.95 volts. Biased sensor, PCM MAF circuit shorted to VREF. P0107CO manifold absolute pressure baro sensor low input checks BP for a signal lower than a specified barometric pressure expected for normal operations when BP is less than 0.04 volts. Default 101 kPa, 14.6 psi. Circuit is open, shorted to ground. P0108CO manifold absolute pressure baro sensor high input checks BP for a signal greater than a specified barometric pressure expected for normal operations when BP is greater than 4.9 volts. Default 101 kPa, 14.6 psi. Circuit is shorted to power. P0112C or intake air temperature circuit low input checks sensor output for a value higher than a maximum probable temperature when IAT voltage is less than 0.15 volts. Default 77 deg. F25 deg. C shorted to ground. P0113C or intake air temperature circuit high input checks sensor output for a value lower than a minimum probable temperature when IAT voltage is greater than 4.9 volts. Default 77 deg. F25 deg. C open in circuit, short to power. P0117C or engine coolant temperature circuit low input checks act for a temperature higher than a specified oil temperature expected for normal operation when ECT voltage is greater than 0.15 volts. Default 180 deg. F82 deg. C. No fast idle. Short to ground on the circuit. P0118C or engine coolant temperature high input checks act for a temperature lower than a specified oil temperature expected for normal operation when ECT voltage is greater than 4.78 volts. Default 180 deg. F82 deg. C. No fast idle. Open in circuit, short to power. P0148C fueling aero engine RPM has exceeded requested RPM. Alternative fuel source, interference on CKP and CMP, faulty PCM. P0196C engine oil temperature sensor circuit range performance checks for an EOT temperature signal which is unable to reach the EOT cold minimum limit when a specified amount of time. Function of initial EOT. In range fault based off of a change in EOT and MFDES faulty, biased sensor, circuit fault, PCM. P0197C engine oil temperature sensor circuit low input checks EOT for a temperature higher than a specified oil temperature expected for normal operations when EOT voltage is less than 0.15 volts. Default 212 deg. F100 deg. C no fast idle. Shorted to ground on the circuit. P0198C engine oil temperature sensor circuit high input checks EOT for a temperature L. Lower than a specified oil temperature expected for normal operations when EOT voltage is greater than 4.76 volts. Default 212 deg. F100 deg. C. No fast idle. Open in circuit, short to power. P0219 engine overspeed condition PCM recorded excessive engine speed greater than 4,300 RPM for more than 5 seconds. Improper downshift, interference on CKP and CMP, faulty PCM. P0230 Corfwell pump primary circuit fuel pump relay driver failure, open control circuit, failed fuel pump relay or PCM. P0231C or fuel pump secondary circuit low voltage present at the fuel pump monitor circuit when it has been commanded on for more than 1 second. Indicates open, short circuit, relay, inertia switch or fuel pump. P0232 core fuel pump secondary circuit high voltage present at the fuel pump monitor circuit when it has not been commanded on for more than 1 second. Indicates short to power, sticking relay. P0236C Turbo supercharger boost sensor a circuit range performance default inferred map low power, slow acceleration, greater than 120 kPa, 2.7 psi at low idle. Map sensor plugged, defective sensor. P0237C Turbo supercharger boost sensor a circuit low default inferred map low power, slow acceleration, map voltage is less than 0.039 volts. Map circuit short to ground or open, defective sensor. P0238C Turbo supercharger boost sensor a circuit high default inferred map low power, slow acceleration, map voltage is greater than 4.91 map circuit short to VREF or VBAT, defective sensor. P0261C cylinder number 1 injector circuit lofacum detected a short in an injector circuit to ground, injector circuit short to ground, defective coil. P0262 cylinder number 1 injector circuit hyphacum detected an open injector circuit open, defective coil. P0263C cylinder number 1 contribution balanceween maximum minimum pulse width adder is exceeded and cylinder does not converge a fault is set. P0264C cylinder number 2 injector circuit lofacum detected a short in an injector circuit to ground, injector circuit short to ground, defective coil. P0265 cylinder number 2 injector circuit hyphacum detected an open injector circuit open, defective coil. P0266C cylinder number 2 contribution balanceween maximum minimum pulse width adder is exceeded and cylinder does not converge a fault is set. P0267C cylinder number 3 injector circuit lofacum detected a short in an injector circuit to ground, injector circuit short to ground, defective coil. P0268 cylinder number 3 injector circuit hyphacum detected an open injector circuit open, defective coil. P0269C cylinder number 3 contribution balanceween maximum minimum pulse width adder is exceeded and cylinder does not converge a fault is set. P0270C cylinder number 4 injector circuit lofacum detected a short in an injector circuit to ground, injector circuit short to ground, defective coil. P0271 cylinder number 4 injector circuit hyphacum detected an open injector circuit open, defective coil. P0272C cylinder number 4 contribution balanceween maximum minimum pulse width adder is exceeded and cylinder does not converge a fault is set. P0273C cylinder number 5 injector circuit lofacum detected a short in an injector circuit to ground, injector circuit short to ground, defective coil. P0274 cylinder number 5 injector circuit hyphacum detected an open injector circuit open, defective coil. P0275C cylinder number 5 contribution balanceween maximum minimum pulse width adder is exceeded and cylinder does not converge a fault is set. 68 DTC house set condition description fault trigger commence probable causes C continuous operation O self test key on engine off KOEO O D cancel flashes R self test key on engine running KOER assigned but not used added changed for 2004 mil malfunction indicator light illuminates. Diagnostic code 69P0276C cylinder number 6 injector circuit lofacum detected a short in an injector circuit to ground, injector circuit short to ground, defective coil. P0277 cylinder number 6 injector circuit hyphacum detected an open injector circuit open, defective coil. P0278C cylinder number 6 contribution balanceween maximum minimum pulse width adder is exceeded and cylinder does not converge a fault is set. P0279C cylinder number 7 injector circuit lofacum detected a short in an injector circuit to ground, injector circuit short to ground, defective coil. P0280 cylinder number 7 injector circuit hyphacum detected an open injector circuit open, defective coil. P0281C cylinder number 7 contribution balanceween maximum minimum pulse width adder is exceeded and cylinder does not converge a fault is set. P0282C cylinder number 8 injector circuit lofacum detected a short in an injector circuit to ground, injector circuit short to ground, defective coil. P0283 core cylinder number 8 injector circuit hyphicum detected and open injector circuit. Injector circuit open, defective coil P0284C cylinder number 8 contribution, Balanceween maximum, minimum pulse width adder is exceeded and cylinder does not converge, a fault is set. P0297C vehicle overspeed condition, vehicle has been driven at speeds above limited speeds, faulty PCM, interference on VSS. P0298C engine oil over temperature condition, function of initial EA checks for an EA temperature signal which is unable to reach THEO thought minimum limit, EAT_hot_LMN, within a specified AMU of time. P0299C turbo supercharger underboost, fault sets when the difference between up and commanded EP exceeds the limit for greater than 30 seconds. Faulty EP sensor, VGT control valve slow to respond, stuck VGT valve, faulty PCM. P0300C random misfire detected, unknown or random misfire when calculated instantaneous crankshaft acceleration exceeds a specified value, a misfire event is detected. P0301C cylinder number 1 misfire detected, indicates when cylinder 1 is misfiring due to a loss of compression. P0302C cylinder number 2 misfire detected, indicates when cylinder 2 is misfiring due to a loss of compression. P0303C cylinder number 3 misfire detected, indicates when cylinder 3 is misfiring due to a loss of compression. P0304C cylinder number 4 misfire detected, indicates when cylinder 4 is misfiring due to a loss of compression. P0305C cylinder number 5 misfire detected, indicates when cylinder 5 is misfiring due to a loss of compression. P0306C cylinder number 6 misfire detected, indicates when cylinder 6 is misfiring due to a loss of compression. P0307C cylinder number 7 misfire detected, indicates when cylinder 7 is misfiring due to a loss of compression. P0308C cylinder number 8 misfire detected, indicates when cylinder 8 is misfiring due to a loss of compression. P0335C R crankshaft position sensor, a circuit PCM monitors CKP signal for a unique pattern to indicate piston position. Checks for total absence of the CKP signal. Poor connection, defective sensor, electrical noise. P0336C R crankshaft position sensor circuit, a range performance CKP signal intermittent. Poor connection, defective sensor, electrical noise. P0340C R camshaft position sensor, a circuit bank 1 or single sensor PCM monitors CMP signal for a unique pattern to indicate piston position. Checks for total absence of the CMP signal. Poor connection, defective sensor, electrical noise. P0341C R camshaft position sensor, a circuit range performance bank 1 or single sensor CMP signal intermittent. Poor connection, defective sensor, electrical noise. P0381C O glow plug heater indicator circuit check, instrument cluster driver checks for open circuit, or short circuit when lamp turns on and off. Open, short circuit, lamp, fuse, PCM. P0401C exhaust gas recirculation flow insufficient detected, EGR valve position does not match desired, limits based on engine speed, load. EGR valve stuck or sticking, EGR valve position sensor bias, EP sensor bias. P0402C exhaust gas recirculation flow excessive. Detected EGR valve position does not match desired, limits based on engine speed, load. EGR valve stuck or sticking, EGR valve position sensor bias, EP sensor bias. P0403C or exhaust gas recirculation control circuit actuator circuit check. Diagnostic circuit associated with 1 amp driver internal to PCM. Open circuit, short to ground, and short to power. P0404C exhaust gas recirculation control circuit range performance plus or minus 0.10 EGRP error from commanded to actual EGRP during normal driving conditions. Faulty EGR sensor, valve or PCM integrity of EGR position circuit P0405C or exhaust gas recirculation sensor, a circuit lower is disabled when EGR voltage is less than 0.30 volts. EGRP circuit short to ground or open, defective sensor. P0406C or exhaust gas recirculation sensor, a circuit high EGR is disabled when EGR voltage is greater than 4.9 volts. EGRP circuit short to VREF or VBAT, defective sensor. P0407C or exhaust gas recirculation sensor B circuit low checks EGR for or lower than a specified position for normal operation. Circuit is shorted to ground. P0408C0 exhaust gas recirculation sensor B circuit high checks EGR for a higher than a specified position for normal operation. Circuit is shorted to 5 volts. P0460C fuel level sensor circuit fuel level indicator FLI circuit check, instrument cluster driver checks for open circuit or short circuit. Refer to the appropriate section in the workshop manual. P0470CO exhaust pressure sensor maximum EPU when the engine is not running 150 kPa 21.8 psi absolute. Faulty EP sensor, PCM. P0471C exhaust pressure sensor range performance minimum EPU when the engine is running, pressure difference of plus or minus 10 kilopascals 1.5 psi from desired. Faulty EP sensor, PCM or VGT. P0472C or exhaust pressure sensor low input EGR disabled, default inferred for VGT operation when EGR voltage is less than 0.03 volts. EP circuit is short to ground or open, defective sensor. P0473C or exhaust pressure sensor high input EGR disabled, default inferred for VGT operation when EGR voltage is greater than 4.8 volts. EP circuit is short to VREF or VBAT, defective sensor. P0478C exhaust pressure control valve high input EP is higher than EP desired by 260 kPa 37.7 psi for greater than 30 seconds. Faulty EP sensor, VGT control valve slow to respond, stuck VGT valve, faulty PCM. P0480C ARFIN 1 control circuit P0487C OREGR throttle position control circuit EGR actuator circuit check, open circuit, short to ground, and short to power. P0488C EGR throttle position control range performance checks for a difference in commanded and actual EGR sets when the difference between EGR and commanded EGR exceeds the limit for a specified time. P0500C vehicle speed sensor a vehicle speed sensor malfunction, sensor, circuit, PSM, PSOM, low transmission fluid. P0528C ARFIN speed sensor circuit no signal P0562C or system voltage low PCM voltage less than 7V, cause of no start misfire, low VBAT, loose connections resistance in circuit, VREF engine concerns. P0563 core system voltage high PCM voltage continuously more than 23.3 versus charging system fault. P0565 core cruise control on signal core switch test code set if cruise not present open short circuit switch failure PCM failure. P0566 core cruise control off signal core switch test code set if cruise not present open short circuit switch failure PCM failure. P0567 cruise control resume signal core switch test code set if cruise not present open short circuit switch failure PCM failure. P0568 cruise control set signal core switch test code set if cruise not present open short circuit switch failure PCM failure. P0569 cruise control coast signal core switch test code set if cruise not present open short circuit switch failure PCM failure. Diagnostic code 70 P05710 brake switch a circuit malfunction cruise control code will be set on every switch test on vehicles not equipped with cruise control. P0603C powertrain control module keep alive memory cam error no historical faults output during self-test. Disconnected discharged battery, open PCM pin, faulty PCM. P06050 powertrain control module read-only memory ROM error PCM failure defective PCM. P0606 CORECM PCM processor P0611C fuel injector control module performance FICM memory fault will set if a RAM or ROM fault exists. P0620 coregenerator 1 control circuit P0623 coregenerator lamp control circuit P0645 CORA-C clutch relay control circuit P0649 core cruise control lamp control circuit P0670C or glow plug module control circuit glow plug control module control line failure open grounded circuit open shorted GPCM failed PCM P0671C or cylinder 1 glow plug circuit glow plug number 1 failure open shorted circuit faulty glow plug failed GPCM P0672C or cylinder 2 glow plug circuit glow plug number 2 failure open shorted circuit faulty glow plug failed GPCMP0673C or cylinder 3 glow plug circuit glow plug number 3 failure open, shorted circuit, faulty glow plug, failed GPCMP0674C or cylinder 4 glow plug circuit glow plug number 4 failure open, shorted circuit, faulty glow plug, failed GPCMP0675C or cylinder 5 glow plug circuit glow plug number 5 failure open, shorted circuit, faulty glow plug, failed GPCMP0676C or cylinder 6 glow plug circuit glow plug number 6 failure open, shorted circuit, faulty glow plug, failed GPCMP0677C or cylinder 7 glow plug circuit glow plug number 7 failure open, shorted circuit, faulty glow plug, failed GPCMP0678C or cylinder 8 glow plug circuit glow plug number 8 failure open, shorted circuit, faulty glow plug, failed GPCMP0683C or glow plug control module to PCM communication circuit GPCM glow plug control module communication line failure open, shorted circuit, failed GPCM, failed PCM P0700 core transmission control system, mill request P0703R brake switch B input circuit core switch test. Open, short circuit, switch, PCM, failed to activate during KOER switch test. P0704CR clutch switch input circuit core switch test. Open, short circuit, switch, PCM, failed to activate during KOER switch test. P1000COROBD systems readiness test not completed. Drive cycle is not complete. P1001R KOER not able to complete, KOER aborted conditions not met. A, C, parking brake, clutch, prindle, EOT, etc. P1102C mass air flow sensor in range but lower than expected. P1139 core water and fuel indicator circuit indicates fault in circuit, faulty sensor, open or short in circuit. P1148 core generator 2 control circuit. P1149C generator 2 control circuit high. P1184 engine oil temperature sensor out of self-test range. Engine not warm enough to run KOEOCCT aborts test. Engine not warm enough, leaking thermostat, circuit failure. P1260C theft detected, vehicle immobilized. P1284 aborted KOER, injector control pressure regulator ICPF failure, aborts KOER CCD test. C codes P2284, P2285, P2286, P2288, P2623, P1334 CREGR throttle position sensor minimum stop performance checks for a maximum closed and a minimum open position voltage. P1335 CREGR position sensor minimum stop performance fault sets when the EGRP closed position exceeds the maximum limit at initial key on. P1378 CORFICM supply voltage circuit low item detects logic power low, less than 7 volts, low batteries, loose connections, resistance in circuit, defective relay. P1379 CORFICM supply voltage circuit high item detects excessive voltage, greater than 16 volts, charging system fault. P1397R system voltage out of self-test range voltage too high or low for glow plug monitor test. P1408 REGR flow out of self-test rangigarc output circuit check, engine off test only. EGR control circuit open, short to VREF, VBAT, ground, defective coil. P1464 or C demand out of self-test range aborts KOER test. A, C switch not in, off, position, A, C circuit short to power. P1501 or vehicle speed sensor out of self-test range aborts test, KOER on demand, CCT, or switch test. VAHI. CLE speed detected during test, faulty VSS, PCM. P1502 or invalid test, auxiliary power control module functioning aborts test, KOER on demand, CCT, or switch test. APCM active while KOER test is running. P1531 invalid test, accelerator pedal movement aborts test, KOER on demand, CCT test. Accelerator pedal incorrect position during test, faulty AP, PCM. P1536R parking brake switch circuit core switch test, failed to activate switch during test, circuit, switch, PCM. P1639C or vehicle ID block corrupted, not programmed. P1703 or brake switch out of self-test range. P1705 or transmission range circuit not indicating park neutral during self-test not in park during KOEO or KOER. Operator error, circuit failure, faulty sensor, PCM. P1725 rinsufficient engine speed increase during self-test. P1726 rinsufficient engine speed decrease during self-test. P2122 core throttle pedal position sensor, switch D circuit low input. P2123 core throttle pedal position sensor, switch D circuit high input. P2127 core throttle pedal position sensor, switch E circuit low input. P2128 core throttle pedal position sensor, switch E circuit high input. P2132 core throttle pedal position sensor, switch F circuit low input. P2133 core throttle pedal position sensor, switch F circuit high input. P2138 core throttle pedal position sensor, switch D. E voltage correlation pedal sensors will use say D, E, F codes. P2139 core throttle pedal position sensor, switch D. F voltage correlation pedal sensors will use say D, E, F codes. P2140 core throttle pedal position sensor, switch E. F voltage correlation pedal sensors will use say D, E, F codes. P2199 C intake air temperature 1/2 correlation between IAT1 and IAT2 are not at expected values. Open, shorted circuit, bias sensor, PCM P2262C turbo, supercharger boost pressure not detected. Mechanical no boost pressure increase was detected. MAFOS, MAP sensor, CAC system leaks, intake leaks, EP sensor, exhaust restriction. P2263C turbo, supercharger system performance. MAFOS, MAP sensor, CAC system leaks, intake leaks, EP sensor, exhaust restriction, exhaust leaks. P2269 core water and fuel condition indicates water and fuel, drain water and fuel separator, defective WIF sensor, circuit integrity. P2284 crinjector control pressure sensor circuit range performance default inferred ICP, ICP desired does not equal ICP signal, difference of 362 psi, 2.5 MPa. See diagnostic manual, ICP system. Diagnostic codes. P2285. P2286. P2288. P2289. C. 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 O. 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 R. 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 Injector control pressure sensor circuit low. Injector control pressure sensor circuit high. Injector control pressure too high. Injector control pressure too high, engine off. Default open loop control, underrun at idle, ICP is less than 0.04 volts. Default open loop control, underrun at idle, ICP is greater than 4.91 volts. Default inferred ICP is used, ICP is greater than 3675 psi, 25 MPa. Default inferred ICP, KOEO ICP is greater than 1161 psi, 8 MPa. ICP circuit short to ground or open, defective sensor. ICP circuit short, VREF or VBAT, defective sensor. See diagnostic manual, ICP system. ICP signal ground, circuit open, defective sensor. P2290. P2291. P2552. P2614. P2617. C. 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 P2623. O. 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 R. 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 Injector control pressure too low. Injector control pressure too low, engine cranking. FICMM circuit, throttle fuel inhibit circuit. Camshaft position output circuit. Crankshaft position output circuit. Injector control pressure regulator circuit. C. O. R. UO101. UO105. UO155. UO306. C. 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 O. 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 R. 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 Lost communication with TCM. Lost communication with FICM. Lost communication with instrument cluster. Software incompatibility with fuel injector control module. Default inferred ICP is used, ICP is below desired pressure. No start ICP is less than 725 psi, 5 MPa. No signal from the FICM monitor circuit. CMPO signal intermittent. CKPO signal intermittent. IPR circuit failure. See diagnostic manual, ICP system. See diagnostic manual, ICP system. Circuit open, short, FICM, PCM. Poor connection, electrical noise. In CMPO from PCM. Poor connection, electrical noise. In CKPO from PCM. Open grounded circuit, stuck IPR, loose connection. 71. Glossary. Actuator. A device which delivers motion in response to an electrical signal. Analog. A continuously variable voltage. APS accelerator position sensor. A potentiometer style sensor that indicates the operator's pedal position. AWA feature. A feature built into the high pressure oil rails used to dampen noises that can be caused by the hydraulic system. Barometric pressure sensor. An analog device which indicates atmospheric pressure which allows the PCM to compensate for altitude. A baro sensor has three connections: signal return, GND, baro signal, and VREF. CAC charge air cooling. A process of cooling the air coming out of the turbocharger before it enters the engine. Canister style oil filter. An oil filter that requires only the element be replaced and not the housing. CAN. A communication protocol for data transfer between the control modules. CKP crankshaft position sensor. A magnetic pickup sensor that creates a sine wave voltage when the timing wheel on the crankshaft breaks its magnetic field. The CKP determines crankshaft position and speed. Closed crankcase breather. A ventilation system that recirculates crankcase vapors into the intake air system. CMP camshaft position sensor. A magnetic pickup sensor that creates a sine wave voltage when a peg on the camshaft breaks its magnetic field. The CMP determines which cycle the piston is in, compression or exhaust. Digital fuel injection. A fuel injection system that uses both an open and close signal to control fuel injectors. Dual timing system. A timing system that uses both a CKP and CMP sensors to determine engine speed and rotational position. DVOM digital volt ohm meter. A meter that uses a digital display to indicate a measured value. Preferred for use on microprocessor systems because a DVOM has a very high internal impedance and will not load down the circuit being measured. ECT engine coolant temperature sensor. A thermistor style sensor used to indicate engine coolant temperature. EGR cooler. A device used to cool exhaust gases before they are returned to the intake air system. EGR exhaust gas recirculation valve. A valve used to control the flow of exhaust gases into the intake manifold. EGRP exhaust gas recirculation valve position sensor. A potentiometer style sensor that indicates the amount of movement of the EGR valve. EOT engine oil temperature. A thermistor type sensor that indicates engine temperature. EVRT control valve. CVGT-CV variable geometry turbocharger control valve. EVRT. The International Truck and Engine Corporation's trademark for its electronically controlled turbocharger. FICM fuel injection control module. An electronic unit which has the primary function of an electronic distributor for the injectors. It also is the power supply for the injectors. Glow plug sleeves. Stainless steel sleeves used to protect the glow plugs from coolant. GPCM glow plug control module. Module which supplies power to the glow plugs and identifies variation in current flow to the glow plugs. 72. Glossary. IAT intake air temperature sensor. A thermistor style sensor used to indicate air temperature before the charge air cooler. ICP injection control pressure. A variable capacitance style sensor used to indicate high pressure oil system pressure. IAT2 intake air temperature 2 sensor. A thermistor style sensor used to indicate air temperature after passing through the charge air cooler. Impedance. A form of opposition to AC current flow measured in ohms. I/O injector test. A test that can be performed using the WDS to disable one injector at a time while watching MFDEs to determine a weak contributing injector. IPR injection pressure regulator. Controls injection oil pressure. An electrical signal to a solenoid creates a magnetic field which applies a variable force on a poppet to control pressure. The quantity of fuel delivered to the combustion chamber is proportional to injection control pressure. IVS idle validation switch. An on-off switch that indicates when the accelerator pedal is in the idle position. KOEO key on engine off test. A self-test operation that is performed with the ignition switch in the on position with the engine off. KOER key on engine running test. A self-test operation that is performed with the ignition switch in the on position and the engine running. Long life ethylene glycol coolant. A premium coolant, with an ethylene glycol base, that can be used in a cooling system for an extended time without needing to be changed. Long-life coolants do not require the use of extenders. Long-life coolants can be identified by its yellow color. Main power relays. 2 battery power relay switches for the PCM and FICM modules that are key power initiated and controlled by the corresponding powered module. MAP manifold absolute pressure. A MAP sensor generates a digital frequency that indicates manifold boost pressure above atmospheric pressure. The signal is created by switching action caused by manifold pressure of a diaphragm connected to a capacitor circuit in the sensor. The digital frequency increases as pressure increases. A MAP sensor has 3 connection, signal return GND, MAP signal, and VREF. Misfire detection. Uses engine RPM changes during a firing cycle to determine a low contributing cylinder. Modular water pump. Is a water pump that uses the front cover as a housing and only the hub and impeller are replaceable. Normally closed. Refers to a switch or a solenoid that is closed when no control or force is acting on it. Normally open. Refers to a switch or a solenoid that is open when no control or force is acting on it. PCM powertrain control module. The housing that contains the microcomputer, VREF regulator, input conditioners and output drivers. Pot potentiometer. Converts a mechanical motion to a voltage value. Most often used to sense the position of a component. This sensor works as a variable voltage divider. The wiper arm is mechanically connected to the component desired to be sensed. Potentiometers have 3 connections: VREF, signal out, and ground. Pulse width. The length of time an actuator, such as an injector, remains energized. 73. Glossary. Relative compression test. A test that can be run with the WDS to measure compression of a cylinder relative to the other cylinders in the engine. This test is accomplished by comparing the RPM of the engine during each compression stroke. Rocker arm carrier. A housing that the rocker arms and their fulcrums are mounted to. Thermistor. Sensor used to determine temperature. A thermistor changes its resistance value in relation to temperature change. Increasing temperature results in decreasing resistance, decreasing temperature results in increasing resistance. The thermistor in conjunction with a current limiting resistor in the PCM forms a voltage divider that provides a voltage signal indicating temperature. Since the top half of the voltage divider is the current limiting resistor and is internal to the PCM, a thermistor sensor only has 2 connections, signal return and ground. Variable capacitance sensor. A sensor that is used to determine pressure. A variable capacitance sensor changes its capacitance value in relation pressure change. Increasing pressure results in a lower capacitance, thus increasing return voltage. Decreasing pressure results in a higher capacitance and a lower voltage. Variable capacitance sensors are 3-wire sensors. VBAT. Battery voltage. VGT variable geometry turbocharger. A turbocharger that has a turbine housing that can change sizes through electronically controlled hydraulics. VGT-CV variable geometry turbocharger control valve. Could also be called EVRT-CV. Controls oil flow in and out of the VGT actuator in order to change the effective size of its turbine housing. VPWR. Battery voltage. VSS vehicle speed sensor. Normally a magnetic pickup style sensor that is mounted on the tail shaft of the transmission to indicate ground speed. 74. Index. A. Actuators, 31. AWA, acoustic wave attenuation, 24. B. Block heater, 35. C. Camshaft, 10. Compressor inlet hose, 9, 18. Crankcase breather, 7, 18, 41. Cylinder balance test, 51. D. Damaged crankshaft trigger wheel diagnostics, 49. DLC, diamond-like carbon coating, 27. Diagnostic charts, 58. Diagnostic trouble codes, 68. E. EP, exhaust pressure sensor, 36, 41. EP tube, 34. EGR, exhaust gas recirculation cooler, 9, 20. EGR throttle plate, 19, 31, 35. EGR-TP throttle plate actuator, 8, 31, 35. EGR-TP sensor, 7, 30. Emissions label, 8. Engine serial number, 41. F. FICM fuel injection control module, 7. FICM electrical connectors, 11, 34. FICM mounting brackets, 7, 11. Fuel filter housing, 35, 40. Fuel in oil diagnostics, 46. G. Glossary, 72. Glow plugs, 10. GPCM glow plug control module, 8, 36, 41. GPCM mounting bracket, 8, 11. Glow plug harness, 7, 8, 31, 35, 41. H. Heater return tube, 35. High pressure oil leak diagnostics, 48. High pressure oil rail plugs, 25. High pressure pump, 27. High pressure pump cover, 15, 32. High pressure stand pipe, 24. Horsepower, 6. I. Injector, 15. Injector clip, 14. ICP block off tools, 50. ICP sensor, 8, 11. Engine wiring harness, 14. 75. Index. ICP sensor gasket, 26. IPR valve, 26. IPR heat shield, 27. Intake manifold, 9, 19. N. No start diagnostics, 43. O. Oil level gauge, 34. Oil fill adapter, 35, 41. Oil filter, 36. Bypass valve, 38. Filter cap, 36. Filter header, 38. Filter housing, 34. Oil pan, 36. P. Power junction point, 34, 41. PCM electrical connector, 46-way, 34. R. Remote mount oil filter lines, 34, 36, 38, 39. S. Sensors, 29. T. Torque, 6. Torque charts, 54. Turbocharger mounting bracket, 21. Turbo oil supply line, 13. Turbine outlet, 35. Turbine wheel, 19. 12-way connector, 36. U. Upper oil pan, 9, 36. W. Water pump, 11. Wavy high pressure oil rail, 24. Wiring diagrams, 60. 76. Copyright 2003 International Truck and Engine Corporation FCs 13930, MISC FCS 13930 MISC 12 thirds revision 0.